to the Journey Chez Chem. Well, today is an exciting day. Just because every day is exciting and we're happy to be here, well, you do those 2 warm-up questions to the best of your ability and we'll discuss them in a moment. In number 1, we are determining the heat of the reaction. And we have a heat of reaction type of problem whenever we're given enough information to determine a balanced equation. And I'm synthesizing water. So hydrogen plus oxygen gives me water. Now, the equation that I'm going to use is that the heat of the reaction is equal to the change of the heat of the products minus the sum of the change of the heat of the reactants. So this big E, sigma, stands for the sum of. So that's why we use the mega brackets. Now, I'm going to have a mega bracket here. There are 2 moles of water. And I know that when I synthesize water here, initially it is going to be a gas. And as it reaches room temperature, it will then condense. But originally, it's going to be a gas. So we're going to use minus 242.0 kilojoules per 1 mole of water. And that's all we have for the product. And on the assessment, I will give you the values of the heats of formation that you need. Now, hydrogen and oxygen are both diatomic molecules, and diatomic molecules, you'll recall that they have a 0 value for their heat of formation because they just automatically can form without requiring any energy. Therefore, we have minus 0. And therefore, my answer is just 2 times negative 242, which would be negative 484.0 kilojoules. Now I must remember that my kilojoules need to be taken to the 10th place. So we have percent composition that's to the 10th place, atomic mass units from the periodic chart that are rounded to the 10th place, and then we also round the heats to the 10th place. Now the sign here is negative, which is telling me it is an exothermic reaction and heat is being released. And that's number 1. In number 2, we are determining the limiting reagent because we are given 2 values for our reactants. And always I have to have a balanced equation. Now I'm going to change my grams to moles, 40 grams of hydrogen, and 1 mole of hydrogen has a mass of 2.0 grams of hydrogen, which gives me 20 moles of hydrogen. I have 16 grams of oxygen, and 1 mole of oxygen is 32.0 grams of oxygen. 16 times 2 is 32. And I get 0.5 moles of the oxygen. Now, I can look at my balanced equation and say that 2 is to 20. 2 is to 20, as 1 is to x. 2x equals 20, x equals 10. And I only have 0.5. Therefore, my oxygen is my limiting reagent. And I'll just continue that with my mass. And I have 1 mole of oxygen for every 2 moles of water from my balanced equation. And then I change my moles back to grams. And 1 mole of water is 18.0 grams of water. Now, this problem can be done in your head. 16 divided by 32 we found was 0.5. Times 2 is 1. Times 18 is 18.0 grams of water. And that would be my final answer. I need 3 significant digits. I go back to my original problem to determine the number of significant digits. However, I could have also solved this one mass and gotten an amount, and that would have given me 360 grams, which is much greater than this amount, and whichever one produces the least amount is my answer to that problem. And there you have it. That's number 2. And you have a review worksheet that you will go over today with your facilitator. And I wish you all the best of luck on your assessment. Bye. See you tomorrow.